Hello everyone, welcome back to the channel. I have got a very special announcement to make today. I am starting a brand new series of one-to-one interviews with leaders in AI and technology and their various subfields to have conversations with my guests on the ideas and the research that they are working on, with a special focus on how they view their work will impact the society and shape the future. To kick things off, I could not have asked for a better first guest. Dr. Peter Cotton holds a PhD in math from Stanford and is a leading figure in quantitative finance, an entrepreneur, and an open source contributor. Peter's career spans senior roles at major financial institutions like JP Morgan and Morgan Stanley. He has also co-founded companies like Benchmark Solutions, later acquired by Bloomberg, and Crunch Labs, where he currently serves as the Chief Scientific Officer. I got to know Peter about 2 years ago when he raised a comment on one of my videos on time series analysis. His comment led me into his book called Micro Prediction, an open AI network, which explores the future of decentralized AI. A book that I highly recommend, especially if you are into making predictions and quantitative techniques in general. Peter is also a major force in the open source community, contributing to Python libraries used by thousands of data scientists worldwide. You should check out his website to get to know more about his ongoing work. This was a great conversation that I had with Peter, and I hope you guys also enjoy it. Should we get started?
Sure.
Yeah. Well, thank you, Peter, for your interest in having this conversation. I am sure myself and the audience of my channel will learn a ton from it. So the topic of this today's conversation is that a few weeks ago, I think, you made in a LinkedIn post, you made predictions for the state of machine learning at the end of year 2025. So I will put a link to that post for our viewers, and we will discuss them one by one in detail. But before we get started, I want to ask you two questions. Number one, I think the predictions that you have made were, I believe, some bold predictions. So I'm very curious to know what, and then as they say, internet does not forget. So I'm very curious to know what motivated you to make these predictions in public. And the second thing that I'm curious to know is that the predictions, we will get to them in detail, but the predictions cover a wide range of areas from decentralized AI, pure math, to prompt engineering. So I'm also curious to know if there is like a common thread or a philosophy that you have that ties all these seemingly different areas together in your mind. So with that, if you don't mind, and then we will, let's view this as an introductory, and then we will get into the details of these predictions later.
Sure. Yeah. Thanks for the interest. I suppose, to be honest, the common thread is probably that they thread through my fairly niche interests and sort of tie together, and some of the things I'm looking at myself. I call them orthogonal predictions because they're not really predictions about machine learning as a whole, more about my my kind of little angle on it, I suppose, that is perhaps different or complementary, hopefully, to other people's predictions.
And then what motivated you to make them in public? Because you are kind of taking it's recorded. You are kind of taking a small risk. They may turn out to be not true. So, what's the motivation? Yeah, I'm just curious.
That's true. I think any downside of being wrong is probably significantly smaller than the investment of time I'm making anyway in things related to this. So I guess there's a pretty small downside, and I just enjoy sort of being part of the public conversation about things to do with AI, machine learning. Really enjoyed being connected to a lot of smart people who are keep me in touch with what's going on in the research world and so forth.
Cool. All right, so I would like to start with your second prediction, which titled is Revenge of Pure Math. And I'm gonna read the prediction for our viewers, and then we will investigate it. So the prediction reads, remember when pure mathematics was considered so useless that UK universities wanted to get rid of it, and Australian universities wanted their math professors to write flowcharts in patent applications all day long. Revenge is nigh. Graduates from the most quote-unquote useless fields, arcane parts of category theory, obscure corners of theoretical computer science, neglected areas of non-commutative algebra, and so forth, will create much more powerful tools than their ostensibly business-focused colleagues. One reason, as syntactic layers of our communication with computers are obliterated, and code generation improves the ability to create and manage complex, nested, recurrent machine creative activity and think abstractly, will be a survival imperative. So, first thing, I hear from this prediction that you have a kind of passion for theoretical areas that used to be underappreciated. Under the areas of the science, here you mentioned pure math that we're not getting the credit that you think they deserve, and I agree. So if that is a good, that's what they intend, then yeah, I'm curious to know where that passion is coming from.
Yeah, I think there's two sides to this. I think one is the raw utility of the tools themselves, which yes, certainly have been historically undervalued, I would say, leading to something of a tragedy of the commons, where society as a whole decided not to invest enough into tackling these hard abstract problems, because it's hard to reward anyone for doing so. Even though if you look back over history, a lot of, certainly all of modern physics was sort of underpinned by mathematical activities, and today you have digital commerce and so forth, everything from cryptography to the rest, all kind of building on top of this. So and that's why a few years back, when universities around the world were starting to go through this brief phase where they were trying to be more commercial and so forth, and that put immense pressure under some of these areas, which I thought was unfortunate. In fact, it got to the point where there was a campaign, to sort of save pure mathematics in the UK, and so forth. Now, I'd say there is the sheer utility of it, and I try to explain why I think that's going to be more useful than ever. Although you already start to see it everywhere. I mean, a few years back, you would say, hey, is Lie theory useful? And now it's taken for granted that's useful in studying, everything from data augmentation to special purpose neural networks that respect symmetries and so forth. And you pick an area of pure mathematics these days, and it has an angle somewhere in machine learning, and say almost without exception. The other side to it is that I think going through that activity of learning about all these different fields and sort of traipsing through the 500 categories of pure mathematics gives you more hooks to hang things on. And so the exercise of doing that, it's really more a comment on on those who have been prepared to sort of go through that process. I think they're going to be quite well prepared for the coming world. It's never so much the things you think you're going to use, in a way where I think we're all analogous to large language models in a way, because if you sort of train on the edge of chaos, as it were, and try to build up embeddings and so forth to carry on the metaphor, then that puts you in a better place to make do high level inference and metaphorical thinking and so forth. So that's why I made that comment to kind of push back. Now, in terms of why now versus before, I think the big thing is that the cost of a project has gone down so much, or the cost of investigating something truly novel. The ratio of kind of pure idea to details and somewhat sort of levels of what I would call arbitrary knowledge in terms of the way we interact, certain rules of everything from rules of syntax to conventions in certain programming packages and APIs and so forth. There's this whole layer of kind of somewhat arbitrary knowledge, and I think Richard Feynman was one of many people who sort of waxed philosophical on this, right? He's like, the knowledge is not the name of the bird; it's the abstract sort of concept. So these days you have all these tools that help you just rip through the arbitrary stuff, but it still leaves behind the task of thinking about the overall structure or the idea itself or the novel connection between two things. And so that's why I see a new kind of empowering of people who have that interest and the inclination, and hopefully they'll be rewarded for not sort of short-circuiting their learning, as it were, by sort of pruning the search too early and thinking, well, that thing I was supposed to learn, that didn't look relevant, didn't sound relevant, so I didn't learn it, kind of thing.
So, sorry, just to make sure. So, do you see this something happening only for example, pure math, or do you also extend it to other branches of science that are kind of theoretical, for example, theoretical physics, as opposed to, I don't know?
Oh, absolutely. I mean,
you extrapolate it.
The general sentiment could apply to all sorts of things. I mean, it could apply to, complex laboratory experiments and so forth. And certainly, I mean, mathematics in the very broad sense of anyone who's kind of trying to use the language of nature, as it were, to get their work done or do so effectively.
So, well, another thing is that the way I read this prediction is that, for me, it sounds that it's based on the premise, at least one of the things that it's based on, is that now the ability to communicate with computers does not have the value that it used to. Being able to communicate with computers is just becoming much, much, much easier. So now, at least the way I understand this prediction, is that now with that, the value of that going away, it will make room for some other things to become valuable. For example, the ability to think abstractly. So now my question is that, why?
I wouldn't say communication per se is easy. What I'm saying is a little more subtle. I think I'm saying that the arbitrary layers of that communication are going away, but communication is still a very important thing, and mathematics is a language. It's a very rich language, and so if you speak it, you can communicate more effectively and tersely to anyone, including a computer.
No, I meant like by communication, I mean being able to communicate with computers through code.
Yes.
So that the value of that is just reducing. The way I understand this prediction is that now that will make room for other things to become valuable, such as the ability to think abstractly. Is that a fair assessment?
Yes, I think so. I'm always very careful, though, of denigrating the art of software.
Mm-hmm.
I think a lot of that is extremely mathematical in its when it comes to sort of designs and architecture and so forth. I would simply say, though, that as you go about implementing things these days, there's an awful lot less that you have to memorize, and there's a heck of a lot more that you can have done for you, starting from an English description or a mathematical description or some combination of the two. So, yeah, it's a very important difference. I mean, it's made a huge difference in my daily work life and that of many other people, and will continue to do so, because even a small kind of reduction in the retry, number of retries, or the error rate, when you're asking for code generation, things like this. I mean, the minute that goes down, just to get smoothed over a little bit, as the next generations come along, all of a sudden that's going to make a huge difference to the chunkiness of this and the sophistication of the tasks you have computers do. Obviously, the rise of agentic systems is going to help that too.
So okay, so the way this prediction is meant is that, let's say one is a pure mathematician. Now that pure mathematician can use these tools, make these iterations much faster, and get to the core, like more things that are more foundational. Is that?
Yeah, I think so. Yeah.
Yeah, and then obviously, if you don't have that knowledge of pure math, then there is just, you cannot use these tools to a depth that a mathematician can. Basically, that's what you are saying. All right. And then, well, the other thing is that if you talk about graduates from these useless fields will be able to create tools that will be very, very valuable. Now, one question that I have is that if a pure mathematician starts thinking about creating tools that will be valued, do you still call that pure math?
That's a great question.
Yeah.
I don't know. It's too tough a question.
You don't know. What's the definition of pure math?
I don't know. It's funny that you don't even hear the expression much in the States. It's just mathematics, right? I guess I did my undergrad in Australia, and it was more of a clear division, I suppose, between pure and applied mathematics. But
and okay, so the well, kind of related question is that so based on my personal experience working with people who were much better than me on the theoretical side of things, for example, a theoretical physicist, sometimes I was getting the impression that they didn't want to use tools such as compute code or software, because they were thinking that spending their time on those tools is just not the most valuable thing that they can do. So a better way of them spending or investing their time would be on working on things that are very, very abstract. So do you talk about these people from these theoretical fields being able to create tools? Now, don't you think that part of the thing that they weren't able to create those tools was because they just were thinking that
yes, that's a fair point, and I hope that at least some of them continue just to build upon that sort of pure mathematical foundation, because both you have to expand the boundary of knowledge and also kind of tie it to applications, but sometimes the latter is not the most efficient way of building up that foundation. Sometimes it's simply better to have people pursue something for its sheer sort of intellectual elegance and build those tools up, because it's impossible to foresee where they will be useful.
But how do you foresee this playing out in industry? I can imagine that in academia, maybe these things will go in that direction. But what about in industry, where the chances of being able to pursue something out of just intellectual curiosity is just it's much lower than in academia? How do you see this playing out in industry?
It's substantially lower. Yeah, I've been a practitioner all my life, so I'm not really an expert on academia. But my prediction was the revenge of pure mathematics, or its denizens, and perhaps I should have said, or its graduates or something. So yes, I think that if there's no particular will or motivation to build something specifically useful, it's probably not going to happen. It's a fair point.
If there's no desire to build something useful, it's not going to happen.
It may not happen directly.
All right. Okay, I see.
You may still build something that's very useful reduced to practice by someone else, but yeah, these are all excellent pushback on my prediction.
Other thing is that maybe it's a little bit off tangent, but it's something that I was a little bit surprised to see happening, and I'm curious to get your input on it. So And one angle of looking into this prediction is that things may move more towards theoretical things, applied versus theory. The theoretical side of things may have a higher chance to be valued. Now, like recently, I'm sure you have heard that the Nobel Prize in physics goes to something that is not theoretical physics. So isn't that a sign that, in fact, things may go into the other direction, meaning that like theoretical things will become less valuable compared to applied things?
I think, well, in that particular example, I would say I think it's one of these cases where, you know, fortune favors the prepared mind, and in that case, it was sort of an interesting journey. I think there was a chess background involved and so forth. If anything, I think that's probably an example of that supports this prediction. But I think there will probably be many more examples like that, where someone with a combination of, you know, practical interest and some theoretical chops and sort of the right sort of disposition for this is able to do surprising things. And let's not forget that, you know, even deep learning, that would at some point was considered fairly pure research in and of itself, especially in the days when it wasn't panning out as people hoped. But it took people to kind of push this along, you know, through that sort of darker times, if you will, irrespective of what other people thought about the practical merit of it.
All right. So now, I think this will be on my last question on your first prediction, and the question is that fast forward 10 years. Okay, and you talk about the tools that can be created now by the graduates of math and etc. That can you give me like an examples of the tools that may be created? You talk about these theories and the prediction that I'm honestly not familiar with, but I'm curious to see like what tools do you envision that these graduates will be able to create using the new tools, and these tools will be used widely by the society, will have very impactful outcomes, and etc. Can you give me examples of these tools?
Well, I think if large language models are any example, it's proof that I am not able to predict that at all. I'm likely to be surprised by the inventions of people. So, yeah, I have no constructive proof for my supposition.
No, not just as a proof, but something like a tool that was so difficult to build previously. Now it's easier to build using at least in the areas that you mentioned there.
Well, I can selfishly speak to some of my own interests. I mean, I've taken a keen interest in the development of you know, decentralized AI and prediction networks and that kind of thing, and that's certainly an awful lot easier now than it was a few years ago.
All right. Okay.
But what other people will do is hard to imagine. It wouldn't surprise me if there's major advances in medicine, transport, manufacturing, and all sorts of things.
Okay, wonderful. So now I think we can move. I would like to move to another prediction of yours, which is prompts become a commodity. So I'm again reading the prediction for our viewers. It says, I'm as guilty as anyone for poo-pooing prompt engineering, but the attempt at trivialization does not stand up to cursory logical scrutiny. Indeed, it quickly reduces to the increasingly indefensible position that humans cannot make any substantial contribution. Once we compare entering prompts to any other activity, such as generating plans, managing subordinates, or entering code into an IDE and producing software, all increasingly blurred distinctions. But in 2025, we will pass a milestone because for the first time, hedge funds will consume and pay for distilled, verified, I think two very important adjectives here, distilled, verified insight in the form of literal prompts themselves, curated from hundreds of thousands of contributions. These prompts, when applied to a sequence of digital artifacts, will generate new alpha and risk factors. So I personally don't have a background in finance, but so this, I think the way this prediction is formulated is more geared towards finance, which I don't have background in. But the way I understand it is that what it says is that people will realize that crafting effective prompts is a non-trivial task to the extent that they will be ready to pay for good prompts. Is that a fair assessment, you think, of this prediction, or any other thing that you would like to add to how I see this?
Yes, and to just to clarify a little bit, so I think some people often will denigrate, quote, prompt engineering because it means lots of different things, too many different things. But one of them is just little tricks for overcoming shortcomings of LLMs. Fine. It may be, by all means, people can continue to poo-poo that if they want to, but the point is that a human being right now is capable of conveying economic insight extremely tersely. And if they know something that's truly insightful on the economic front, then they can turn that into a prompt, which a large language model can interpret. It can take that economic intuition, a financial intuition, political intuition, whatever it is. It might be a question about a clever way of discerning if a company is likely to be found guilty of fraud. It might be some way of predicting inflation, who knows. But if that intuition is taken by the LLM and then used at scale to quantify the world, the history of the world, to enable machines to see the world as they've never seen before, then it's going to be valuable. And for most of my career, I was building mathematical models for finance, for other things, and there's always a frustration that the model itself can only see 1% of the universe. Now, with large language models and clever, insightful prompts, you can start to instrument everything in the past in a way you couldn't do before. And honestly, the best way to do this is just give someone a tool. And so, here I really am talking my book. I mean, I created a little tool, Pi, crunchdown.com, and you can just type in prompts as a way of interrogating central bank statements. And it will go back over history and will assign scores. And then it will tell you if your scores are correlated with returns of stocks or other things that are likely to be sensitive to central bank announcements. So that's just the very beginning of this sort of instrumentation of everything. And if you talk to portfolio managers, people on the buy side and so forth, who are trying to develop alpha strategies, systematic or discretionary, they're...
Sorry, what is alpha? Yeah, so again.
Oh, yeah, sorry.
Yeah.
If they're trying to beat the market, if they're trying to discover some characteristic of a company, let's say, that is predictive of its future performance, of course, there's hundreds of factors out there that are well known and publicized, but there could be completely new ones that we haven't used before simply because the data wasn't there. And there could be different ways of thinking about the macroeconomy using data that we simply didn't have before. I'll give you a little example.
Yeah.
So suppose you go back over every FOMC statement in history, every central bank statement from any country, and you say, give me a score of 1 to 5 of whether this statement contemplates helping out people who are less well off. Score of 1 to 5. That generates, as many different time series as you have central banks in your database, and those numbers may well be correlated with future returns of interest rate sensitive products. Because, and I won't reveal the sign here, you have to try it yourself, but maybe the market likes it when the central bank has some considerations like this. Maybe it hates it. It's just an example. Another example would be, to what extent does this statement contemplate the dangers of imported inflation? Or, is there fear of industrial action, or things like this? There's a million different ways you can instrument every digital object in the past. And so we are just at the very beginning of that huge mapping enterprise. And
okay, so all this coming through the
prompts,
all this coming through these prompts, questions. You mentioned that these distilled, verified prompts that curated from hundreds of thousands of contributions.
Yep.
Why does it need to be from the hundreds of thousands of contributions?
Because insight is distributed across people, across the world, in many different ways. You never know who it's going to come from. And it's a needle in a haystack. So you need a pretty big haystack. Bigger the better, to get outside your own ways of thinking about things, to take advantage of the cognitive diversity, to take advantage of the geographical specifications. There's someone in Brazil who lives next to a port who has some real insight into their imports and exports that you don't have. The world is full of this kind of local knowledge that some people possess and most do not.
So you mentioned a few examples in the field of finance, but I'm also very, very curious to see how you think something similar to this may influence other industries, specifically just something that I'm interested in, education, for example.
Yeah, education, that's an interesting one. I haven't really thought about that, but of course, education has an enormous amount of exhaust, if you will, and sort of the written statements of students and the assessment of the same and so forth, and who knows what you could discern about someone from that. Yeah, I think just thinking about uses elsewhere. I mean, we saw an interesting example just recently, which was painful to me because I've been sort of advocating this forever. But in the fires in California, we saw the official kind of predictions and directions being rapidly supplanted by community efforts because the official instructions were erroneous. And so you saw this hastily put together kind of community crowdsourcing of alerts and information. If that was more organized and you had a pre-existing sort of prediction web, and people could just had already written algorithms that consumed information from LLMs and turned that into quantitative information that could be used on the ground, then the situation might have been quite different. So whether it's scouring news reports for current events, or looking at traffic, industrial processes, operations inside companies, you name it, like everything can be instrumented now in very novel ways. But it is limited by your imagination, for better or worse. So it's generally best to see if you can use other people's imagination as well.
Doesn't that kind of open it up to like people manipulating this system? Like, I think it's fair to imagine that some people may not have the best of intentions, and if they are open to inject their insights into this system, wouldn't that?
Oh yeah.
I guess what I'm asking is that how would you control who is getting a chance to influence the system and who is not?
So every
like, for example, if you use it, for example, in the finance to predict the performance of a company using a system like this, can people go and insert insights to manipulate the system?
Well, those making the statements could manipulate the system or attempt to, but that's already the case. Company statements are already kind of reverse engineered in fairly elaborate ways with knowledge of the way they'll be interpreted. I think it's less of a problem for the FOMC and others. I mean, every crowdsourcing mechanism, every market, every way of aggregating information needs to deal with the problem of noise. But this is fairly well advanced. Market mechanisms have their own way of dealing with it. Crowdsourcing mechanisms use things like expectation maximization, and so it goes. So yes, it's not perfect, but it tends to be the least worst system for aggregating information.
Well, I think now that I'm thinking about it again, I think you're just mentioning that this will be valuable for people to get paid for. So the person or the organization that pays for it can decide to how to use it or not use it. So that's kind of
exactly right.
Yeah.
Yes, and of course, there's mechanisms that we put in place that consider the originality of the prompt as well as its apparent economic relevance. And then, as you mentioned, on top of that, ultimately it's those that are perceived as valuable.
They decide what to do with it.
Yeah.
All right, now the third prediction, collective AI will infiltrate the bid offer. So I'm again reading it. Decentralized artificial intelligence has reached the upper tier of influence with the likes of Peter Thiel and Vitalik Buterin, the co-founder of Ethereum, piling in. Web3 communities are not waiting for the rest of the world to grow the possibilities, which are at the basic level pretty elementary Hayekian economics. But Wall Street has hardly been threatened today by the likes of Numer AI, and it's, by the way, hedge fund that uses machine learning models curated by a global network of data scientists to inform its trading strategy, or offers pay or others paying bid offer, and this mode has repelled the itinerant algorithms from latent alpha potential. Has repelled the itinerant algorithms with latent alpha potential from achieving the rent extraction they need to self-sustain. That will change when the ability to be compensated for marginal prediction contribution is not thresholded by that barrier. So, what does paying a bid offer mean, and how has that prevented these algorithms from self-sustaining?
Yeah, so paying the bid offer simply refers to being a price taker, if you will, as if you were to submit an order to buy a stock, and typically, at market, as it were, then you're going to trade, and somebody else who's a liquidity provider or a market maker, on average, will make a small amount of money out of your trade. And so the only real way to trade by avoiding that is to participate in some way that's more like being a market maker. But of course, that takes time and effort, and in some cases, in many cases, also requires you to do things like have be a broker or something, and spend a year getting a broker's license. So these are kind of off the table for most people, certainly for most algorithms. So there's kind of a fixed cost or a threshold, in the sense that if you're a imaginary sort of lightweight algorithm, and in theory you could support yourself and your CPU cycles for 10 cents a month or something, it's not necessarily easy for you to generate 10 cents in alpha, because you have to pay this threshold. But if there's a different mechanism, and there is now, where anyone who can find a tiny amount of predictability can be rewarded for it, without that, meeting that bar, then all of a sudden you have the possibility of algorithms kind of starting from zero and growing up and earning a bit of money and so forth. And who knows, the possibilities from there are endless. They could turk out improvements to themselves and so forth.
And it's a decentralized AI that is providing this possibility. Because
yes,
there's an institution like Numer AI collects marginal improvements in predictions, collects them all together, and then does what it does with it.
Yes, to some extent, although Numer is still paying the bid offer themselves, and yeah, so it's tricky. Actually, what Crunch is doing is different. So we actually work with over-the-counter market participants, and we've engineered a way to avoid this, paying the bid offer, as it were. There are many interesting examples of crowdsourcing in the financial sector all over the place. WorldQuant, Quantopia, Numerai, and so forth. And they all come at it in different ways, but I think if you're able to kind of break down the task and not ask an algorithm to do everything and completely reproduce the operation of a top tier buy side firm, then it has but they can still get rewarded for doing some component of the work, then that seems to work better. And there's examples of that, including WorldQuant and Crunch and others.
But this reward for the marginal contribution is still coming from
it ultimately comes
from an organization like Crunch or New.
Yeah, that's right. That's right. Exactly. It's coming.
So you are not getting really rewarded directly for your marginal contribution, but because of the
That's right.
the effect that your contribution has when it's combined with other marginal contributions. That's why you're getting. Okay, right. All right, wonderful. And now we go to the last prediction, which is extreme statistics. So the prediction reads: high quality statistical components such as bespoke noise resistant Kalman filters for control systems, microstructure regime detectors for finance, and custom optimizers will be produced in a spec-first manner and deployed in real-time systems. The generative models and evaluations will be written or learned first, akin to the practice in extreme programming of obsessively writing the tests first. This isn't new, but agent systems and ML crowdsourcing will make it much easier and more effective. So the way, maybe it's the wrong angle to look into this, but the way I am looking into it is kind of related to the first prediction, a revenge of pure math. So it's kind of saying that now with the agentic systems, it will be possible to build, for example, custom optimizers, which obviously requires some good grasp of the theory there, math, and that this was again like linked to the first prediction that this will reward in those fields getting the recognition that they deserve. Is that the wrong angle to look into it, or is that fair assessment?
I would say the common thread is that a lot of gains will be made if you can provide the new technologies with targets and feedback. And so I think we would all agree that the generative power is kind of off the charts these days. Everything from code generation to systems that take advantage of code generation. And as you mentioned, agent systems, of course, being all the rage with good reason. But usually, or not usually, but sometimes what is lacking in these exercises is having that really hard feedback or that very well-defined task. And so I think there is a huge opportunity right now to revisit some of these basic tools of statistics, of control theory, of engineering, and write a specification for what they need to be. That specification can take various forms, but one of them can be, here's a complete generative model that simulates many different kinds of systems under different parameter regimes and so forth. And this will simulate a process. Let's say it might be some noisy, complicated process that throws off measurements. And that sets up a well-defined filtering task, let's say, where the goal is to either discern some latent state or make accurate predictions of something that's thrown off by the system. And so by creating that extremely well-defined task, you can write the test first, as it were, and then you can say, well, what is the right algorithm? What is the right approach? And you can simply let the agents, the crowd, combination of the two, generate as many possible scenarios as it takes, and that's always going to be constantly improving. And then if you have an efficient way of taking the result of that and taking these high quality components and putting them back into industry in a place where they're very useful, then that can be I think a very good use of generative technologies.
Sure. And do you know of any applications that are desperately in need of such high quality, specific, like high quality custom components, such as you mentioned, noise resistance Kalman filters? Are there any applications that are desperately in need of such these components? Meaning that, for example, can you think of a thing that was not possible before, but now with this spec-first statistical component may be possible?
Yes, I think, again, unfortunately, hobbled by my own sort of limited field of vision, I would say market microstructure is one key area, because even if you believe the generative model for the market and the way in which all the players are behaving, it's usually intractable to perform the kind of Bayesian inference that you would want to do in theory. So trying to understand the granular behavior of the market at a short time scale is a very good example of this, limited by your ability to create reasonable generative models in the first place, of course. Now, speaking more speculatively, just because it's not really my field, it's hard for me to imagine that this same type of approach can't work well in other areas like aeronautical engineering and so forth, or potentially in weather prediction, and possibly lots of other places, in everything from sort of computational biology to who knows what. I would think that autonomous systems, another great example where the system is tasked with trying to assimilate awkward measurements of the world that possess structure, and being able to do that inference very quickly can be enhanced by potentially trying to set up some of these games, if you will, and then determining who can play them the best.
Well, I think, but the question will still remain whether, like, the delta, this alpha, the extra benefits that you get by a tool that is spec first, is really significant compared to something that already exists, that is not spec first, for example. So that's still the question that I have. Oh,
it certainly is, but I would say that if I was to pick if you take it. You could easily point to an over-the-counter market where the kind of total compensation for doing this, is on the order of $200 billion a year, done by market participants in various ways. And so if you could imagine this works perfectly, and out of this experiment comes an algorithm that performs that task, then it's substituting for some reasonable portion of that, and that's coming from my, again, slightly sort of biased or limited view. In other applications, I can imagine it would be more important, if not less, when it comes to looking at sort of critical real-time systems where lives are at stake. These are very, very tough problems, and the set of tools we have in statistics for where you know what the right answer is, and it can be computed quickly, and you have the theory to back it up, it's actually extremely limited. I mean, limited in all sorts of ways, limited by the small number of things that have conjugate distributions and practical things like this. And so that's why I see a shift from trying to sort of build up from some of those classic constructs to simply trying to say, wait a minute, look, here's the generative model. And show me over millions of simulations what really is the best solution to this, irrespective of the approach. Setting aside, by the way, the fact that this is also relevant to, sort of, $15 trillion of assets under management, and the way that's the way the portfolios are constructed, it's also relevant for that too.
All right, wonderful. I think we are up to the hour right now, so I think we have covered all the predictions that you had in the post. So I don't have any other questions about your predictions. If you want to add anything, please feel free, and maybe like next year we can meet again and see. Yeah,
absolutely. I have no real comment other than the sort of hackneyed phrase, whose acknowledgement I'm afraid I've forgotten that. I think there's some truth to it, right? If you want to predict the future, the best way is to try to engineer it.
Actually, I just read in a LinkedIn post that came to my feed that inventing the future is easier than predicting it.
So I should probably get busy on some of these. But yeah, no, we are obviously working on some of these predictions, and but yeah, hopefully it's just an interesting conversation starter, if nothing else. And
yeah, absolutely.
I'll be quite wrong about most of them, but
I think I certainly enjoyed reading about these predictions, thinking about it, and having a conversation. And I'm sure that will be the case for a lot of the audience who watch this video.
Yeah, well, I'll have to discuss it more.
Yeah, sure. Well, thank you so much for your time. Appreciate it, and good luck with everything. Hope to talk to you soon again sometime.
Thanks very much.
Yeah.
This was fun.
Yeah, thank you. Bye.
Yeah.